Hello everyone, welcome back to LeetCode, and today let's practice LeetCode number 289, Game of Life. So we are given a matrix or the board, and every value in the board is either 1 or 0 that maps to live or dead in the current status, but it will become, in the next status, it will become either died or live, which is decided by the neighboring neighbors. Like in the first rule, it says that any live cell with fewer than 2 live neighbors dies. Okay, so here are some rules, and here are some examples. And at first sight, it seems like an easy problem because we can use some temporary matrix to keep the updated value in that temporary matrix, and then we can copy the updated value from that temporary matrix to the board. So we have an updated board, and then return that board. But in the follow-up question, it says we have to solve this problem in place. It means that we cannot use a temporary matrix to keep track of the updated value. So what problem we will encounter? Let's see. So here, let's use the example. Here is a matrix. So if we want to count, here is a matrix. If we want to count the next status of this cell, what will it be? So since it's surrounded by 3 live neighbors, these 3, so its next status will become a 1. And after we finish this row, then we want to finish this row. So when we want to update this cell, we will look into his neighbors. So it has 1, 2, 3, and 4 neighbors. So for the row, when it has 4 neighbors, it will become dead in the next status. But actually, this status, the 1 is the updated status. It is a 0. Currently is a 0, so it is currently dead. So for this cell, it should be 1 because it is actually currently surrounded by only 1 and 2 and 3 live neighbors. So it seems like we cannot update the matrix directly and at the same time keep its old value. So how can we solve this problem? So we have to have 2 digits like this to be put in every cell to keep track of his current status and the next status of that cell. For example, I have a 0, 0 here, and the rightmost bit, it means it is currently dead, and then it will also be dead in the next status. So in here 0, 1, it means it's currently live and then will become dead in the next status. In this one, 1, 1, it means it is currently live and then also remains as a live in the next status, so it is a 1, 1. And then the 1, 0, it means it's currently dead and will become live in the next status. So in every cell, we will update its value to this 2 bits or binary representation, and then after we have this this binary representation, and then we will use some trick to only get his current status. So let's see. If we want to get, so after we first iterate the matrix, we have this updated value. So it's a binary representation. And how do we guess the current status? So we can use the cell number and use a bit operator, which is N1 to guess the last digit. Like the example, if now this is a 1, 1, and then if we use N1 here, so it will help us get the 1, so it will get the last digit. Or if it's a 1, 0, and then we use N1, it will we will get the 0, so it is the last digit. So we will use the N1 to get the current status. And then how do we get the next status? So we can right shift the cell value by 1. So like this, if now it is 1, 1, and then we'll right shift by 1, it will become 1. So it is the next status. And if it is now 110, and then we right shift by 1, we will get 1. So it is also the next status live here. Okay. So now let's jump to the coding part. Okay, so first, let us check some edge conditions. So it means when the board is null or there is nothing in the board. So, okay. So we will return in this edge condition, and then I want to have 2 variables to keep track of the size of the board. So I will use row, upper capital row, to keep track of the length of the board. And com to keep track the width of the board. Okay, so first I will use the first iteration to make the cell to become the binary representation of that cell. Or so at the same time I will update, or I will guess both the current status and the next status of each cell. Okay, I use R equals 0. I want to know what is the live neighbors of currently visited cells. So this is a function, and I will implement it later. So I will pass the board in row and column and the current location and the location of the current cell. Okay. So here I want to consider want to count the live neighbors of the currently cell. Okay, so I pass in the board. Okay, so first let me initialize a value that is lives. It means the live neighbors. So initialize this as 0, and then I will check all the neighbors of the currently cell. So for, let's say, I will use I and J to be used to visit its neighbor. So for the neighbor, for R, I have the I. It should be range from I -1 to R plus 1, and then also for the J, and then I want to check if the I and J is still in the boundary. So here I can check if IJ in the boundary, and then next I do not want to visit the cell itself. I just want to count these live neighbors. So I have to exclude the cell from the iteration. So when the I equals to R and the J equals to C, it means it's the cell. So we want to exclude it. So we have a not here. So we will use, we want to get the current status of the cell. So we'll use N1 to get the status. So that is the board I and J, and okay, and N1 here. Okay, and after I visiting all of the neighbor, so I can return the lives. Okay, so here after I have the live neighbors, and then I want to check what should be the next status of the of the current cell. So now if current cell is live, and what so here in the rows, so first row it says okay, so here it says if the live neighbors is from, or are the number of live neighbors is from 2 to 3, then the cell will remain live in the next status. So I will update the cells to become a 3. So it is in this condition, so it is currently live and will also remain live in the next status. So 1 in binary representation is a 3 in 10th base representation. Okay. Then I want to check if the current status is a dead, and then it will become live in the next status. So this one comes from the rule number 4. Okay, so here I want to update it to, so it is now dead and will become live in the next status, so it will become a 2. So you may wondering why I just consider the live. Well, I just update the status when the cells become live or remains lives in the next status. Okay, that is because if the cell becomes a dead in the next status, and then after I will use the right shift by 1 to get the value of the next status, right? So I want to get a 0 here because there is a dead. So the number I want to get is a 0. Since before I update the number in the matrix, all the numbers are either 0 or either 1 in the matrix, and then I right shift by 1, then it will always get me a 0, or this one I right shift by 1 and also get me a 0. So I don't have to update the number because after its right shift, it will always give me a 0. So here I just have to consider when it becomes alive. So okay. So for this iteration, our matrix will becomes like this, like it's a binary representation value, and then we want to only guess the leftmost digit. So okay, I can just copy from here. We can iterate the matrix again, and then now I want to update the value to get only the next status of the value. So I will use right shift by 1 to get that number. Okay, so that is the whole code. Now let's submit. Okay, another statement. Oh, sure. I should say else if all right. Oh, I just use the I++. Okay, now let's submit. Okay, pass. Thanks for watching.